In this video, I'm going to explain to you how to determine which molecule has the highest boiling point. A boiling point is the point in which, or temperature in which the liquid turns into the gas phase. To understand boiling points, it helps to understand first the process of vaporization. For a liquid to vaporize, it needs to overcome its intermolecular forces. A good way to think of this is, when you add water to a container, it doesn't disappear instantly. It doesn't vaporize as soon as you pour it into the container. This happens because not all the molecules in the sample have the minimum kinetic energy to overcome the intermolecular forces. So, for this to happen, energy has to be added into the system, and that's why you boil water. You add heat to it so it can overcome those intermolecular forces and reach its boiling point. It's also good to know that the minimum kinetic energy required to overcome intermolecular forces is called escape energy. Going back to the example, the minimum amount of heat required for the water to boil is called escape energy. And then what this means is that when we have strong intermolecular forces, we need more energy to separate those forces, and therefore we have a high boiling point. So, to make it simple, a molecule that has strong intermolecular forces will have a high boiling point. Now let's try some problems to understand this better. Let's say we have water. So H, let me change the color. H, and we have diethyl ether. That is H3C. Then we have a carbon here, oxygen, carbon, CH3. This is the same as just writing a C here. I'll just write it, it's the same. The first thing you'll want to do is see what intermolecular forces each of them have. So we'll make a table. This is going to be hydrogen bonding, H, dipole, and London dispersion forces. So water has hydrogen bonding, so we can check that. Diethyl ether has no hydrogen bonding because it has no hydrogen bonded to a fluorine, oxygen, or nitrogen. So we'll just leave that blank. Water has dipole forces. Whenever you have hydrogen bonding, you will usually have dipole, and every molecule has London dispersion forces, so we can check that for both. And for the case of diethyl ether, it does have dipole forces. Also, none of these are ions, so we can omit anything that has ions, like ion-induced dipole or ion dipole. Recalling what I mentioned before, strong intermolecular forces mean a higher boiling point. So out of these two compounds, water has stronger intermolecular forces, meaning it will have a higher boiling point. Diethyl ether, on the other hand, doesn't have such strong intermolecular forces, although the forces are still strong. The boiling point is going to be lower than water's, but it doesn't mean it's going to be low. And for water, the boiling point is 100 degrees Celsius, and for diethyl ether, I think it's less than 50, so it makes sense. The two previous cases were were polar molecules, sorry. When we talk about non-polar molecules, it can get a little bit more complicated. Non-polar species or non-polar molecules have London dispersion forces, which are usually very weak. However, some non-polar molecules can have higher boiling points than compounds that have hydrogen bonding, like water. And this happens because of two factors. Those factors are molar mass and the size of the electron cloud. As we proceed down a group in the periodic table, the molar mass and the size of the electron cloud will increase. So we have an increase. But what this means is that as the electron cloud increases in size, the species will become more polarizable. And something becoming more polarizable means it will have stronger London dispersion forces. Stronger London dispersion forces are stronger intermolecular forces, increasing the boiling point. To think of this, I'm going to show you 4 different nonpolar compounds. We have fluorine, F2, we have chlorine, bromine, and iodine. Fluorine has the lowest molecular weight at 38. That's in AMU, of course. And iodine has the highest molecular weight at 253. Now the boiling point for each of these is 85.1. Then for fluorine is 238.6, 332, and finally 457.6. And this goes back to what I just explained about molar mass and the size of electron. Iodine has the highest molar mass, which means it has the biggest electron cloud. It's the most polarizable, and therefore it has the highest boiling point. Whereas fluorine has the lowest molar mass, and it has a very small electron cloud, which makes it hard to polarize. LDFs are very weak, and then the boiling point is not very high. So this was just to show you that non-polar molecules can still have a very high boiling point. Like chlorine has a higher boiling point than water, even though water is polar and chlorine is non-polar. So you have to take into account intermolecular forces, and in that case molar mass and the size of the electron cloud. And well, that was it for boiling point. If you found the video helpful, like it and share it with your friends.